Hi everyone, this video is on question 3 from exercise 9G of PO2. So this is again the classic example of finding the equation of the normal to the curve using differentiation. But this time the difference is that we have parametric equations. So the usual recipe is the same. We first need to find the derivative and then find the gradient of the tangent and just tangent line and continue as usual. So dx dt, that's the first step because we should find dx dt, then divide dt, and then divide dx from that. So dx dt is equal to the exponential function has just the same derivative, so it's e to the t, and divide dt, e to the t differentiates to e to the t, e to the minus t, so the derivative of minus t is minus 1, so minus 1 comes down and it becomes minus e to the power of minus t. So now we can find divide dx. Divide dx is equal to divided t divided by dx to t, and this gives us e to the t minus e to the minus t divided by e to the t. We can simplify this, so we can divide both terms in the numerator by the denominator. E to the t divided by e to the t is 1, and minus e to the minus t divided by e to the t is minus e to the minus 2t. So this is the derivative, which means that we can use this to find the equation of the tangent line. Just remember that we want to find the equation of the tangent line at the point P where t is equal to pi over 6. This is crucial for us because if we don't know the value of t, then we can't find the exact value of the gradient and then continue to find the equation. So we now substitute t into divide dx, and that allows us to get the value of the gradient of the tangent line. So when t is equal to pi over 6, we are going to have divide dx is equal to 1 minus e to the power of minus 2 times, sorry, I made a mistake because this t is equal to pi over 6 is for part B. Sorry, for part A. It still is the same principle, but the t value is just 0 this time. It's not pi over 6, sorry. So t is equal to 0. That means we substitute 0 into t. So 1 minus e to the minus 2 times 0. So this is interesting because what we are going to get is that e to the 0 is just 1, and 1 minus 1 is 0. So what we got for the value of the gradient of the tangent is 0. And what does this mean? Because usually we don't get 0. We tend to get non-zero values for the gradient of the tangent. So when the gradient of the tangent is 0, that means the tangent line is a horizontal line. So that's very important. And consequently, when the tangent line is horizontal, then the normal line is vertical, because normal is perpendicular to the tangent line. So it must be a vertical line, which means it's parallel to the y-axis. So what does this mean for us? Because normally when we find the gradient of the tangent line, then what we do afterwards is that we say, okay, the gradient of normal is equal to the negative reciprocal of the tangent, which is 1 minus 1 over 0, which is undefined, obviously. So we can't use the general approach because that doesn't work here. But what we can do instead is that we just need to use a trick that applies to this specific type of questions, or when we have parametric equations, because we already know that the value of t is 0. So now let's substitute t is 0 into the two equations of x and y to get the values of x and y when t is 0. So when t is equal to 0, x is equal to e to the t, which is e to the 0, which is 1, and y is equal to e to the 0 plus e to the minus 0, which is 2. Okay, this part is very interesting and also very important to understand. Because what's happening is that I'm just going to use just a simple diagram. This diagram is not for this question. It's just a very simple diagram. So whenever you have a curve, let's say we just have a simple quadratic, and then we have a tangent line to that. And when we want to find the gradient of the normal is the perpendicular line to the tangent line, which is, let's say, going to be something like this, because this is the point that we are considering. Now, why did I show that? Because in this case, the points that we are concerned with is the points with coordinates 1 and 2. We just substitute the t is equal to 0 into the equations here, and we got the value of the point P, let's say. And we obviously found that the gradient of the tangent line that goes through the point P is just 0. So 0 means that the tangent is a horizontal line, and we know that normal is a vertical line. Normal is perpendicular to tangent, so it must be a vertical line. And the interesting thing is that the vertical line to point P must have the equation of the form x is equal to a constant, right? Because vertical lines are parallel to the y-axis, and they have the equation of the form x is equal to a constant. And in this case, the constant is simply just 1. So the equation of the normal is this, is x is equal to 1. And that's just because the normal is a vertical line and is parallel to y-axis, and it obviously passes through the point P. So it just we just have one option, right? So it's the because again, tangent is horizontal, don't forget that. So the normal is perpendicular to that, and that's the reason that the equation of the normal is x is equal to 1. Okay, part B. So part B is basically the same thing but with different equations. So the equations of x and y are as the following. So x is 1 minus cos 2t and y is equal to sine 2t. So we want to find the equation of the normal when at the point P when t is equal to pi over 6. So the approach is very similar, and we find the x to t first. So minus cos 2t, minus cos differentiates to differentiates to positive sine. So in this case, we have 2t inside, so 2t differentiates to 2, so we will have 2 sine 2t. And then for y, dy dt is equal to sine 2t differentiates to 2 cos 2t. So we now need to find dy dx, which is equal to dy dt divided by dx dt. So dy dt is 2 cos 2t. Dx dt is equal to 2 sine 2t. And this is equal to cot 2t. Again, we want to find the tangent at the point P when t is equal to pi over 6. So we substitute this to get the equation of the tangent line when t is equal to pi over 6. So dy dx is equal to cot of 2 pi over 6. And this is simply equal to root 3 over 3. But remember, we want to find the equation of the normal. So the gradient of the normal is a negative reciprocal of the gradient of the tangent line. So the gradient of normal line is just equal to the negative reciprocal of this, which is minus 3 over root 3. And we can rationalize the denominator. We get minus 3 root 3 divided by 3. Simplifying, we get minus root 3. So minus root 3 is the gradient of the normal. We have one more step before finding the equation, which is now finding the coordinates of point P. So this step is very simple. If we want to find the coordinates of points P, we just substitute t is equal to pi over 6 into the two equations above, x and y. So when t is equal to pi over 6, x is equal to, so x has the equation 1 minus cos times 2t. So 1 minus cos, t is equal to pi over 6. So 2 times that is this. And then the value of y is sine 2t. So sine of 2 pi over 6. And now we calculate these values. So x is equal to a half and y is equal to root 3 over 2. Now we can form the equation, because ultimately we want to, so p has the coordinates half root 3 over 2, and we want to find the equation of the tangent of the normal, and the gradient is also minus root 3. So now we are going to use this famous equation, y minus y0 is equal to m times x minus x0. So y0 is the coordinates of p, root 3 over 2. M is minus root 3. And x0 is a half. Now it's just a matter of simplifying to get it in a nice form. So y is equal to, let's first expand and then add root 3 over 2 to both sides. So if we expand the bracket, we have minus root 3x plus root 3 over 2, and then adding root 3 over 2 to both sides, we then get y is equal to minus root 3x plus root 3. And that's it. So this is the derivative. This is the equation of the normal. So that's it for this video, and thank you for watching.